In this video, we are going to look at how to come up with derivatives for trigonometric inverse function. Okay, so I'm going to start with the first one. Let's start with sine. Okay, if we have the inverse of sine of x. All right, so what you do is that you let y be equal to sine inverse of x. Then you switch. The moment you switch, it means that you've already dealt with what? The inverse. Then you differentiate with respect to y, which will give you cos y. Now we are looking for dy dx, right? Meaning this becomes 1 over cos y. But let's go back to the relationship which is there between sine and cosine squared. Okay? Making cosine here the subject of the formula x, this will give us plus or minus root of 1 minus sine squared what? X. Now, in the interval pi over 2, in the interval negative pi over 2 and pi over 2, here cosine x is what? Positive. It's positive. Meaning that we are only going to get the positive part of this 1 sine squared x. But from the beginning, what is sine y? Okay, in our case, we're going to put y there and y, then y, then y, then y. In our case, sine y is actually x. Meaning what we have here is 1 over root of 1 minus sine squared y, right? 1 over 1 minus, what is sine? Is x. And you are done. Okay, now let's go for cosine. It's the same scenario. If you are given f of x is given by cos inverse of x, so we say y, all right, y is equal to, it will be the same, even the relationship which they share here, it will be the same. So I want you to do for cosine. We move on to third one. If I give you f of x is given tan inverse of x, so we say y is equal to tan inverse of x. You switch them, x comes there, then tan y goes there. The moment you switch, you are done. Then we differentiate with respect to y. This will give us sec squared y. Of course, the derivative of tan is just sec squared y. But we are looking for dy x, which will give us 1 over sec squared y. Let's go to the relationship which is there between sec squared and tan squared. All right, do you recall the relationship? So because tan squared y plus 1 is equal to sec squared y. This is a very nice relationship between these two guys. Meaning when there is sec squared, we are going to put sec squared, we are going to put tan squared plus y. You need to know these relationships because they are identities and they are very interesting to use in here. Meaning we have dy dx is equal to 1 over, we put tan squared y plus 1. Meaning 1 over, what is tan? Tan is x. So meaning you are going to have x squared plus 1. Can you fail to find for if I give you y f of x is equal to sec inverse? To be the same, it will just give you 1 over x there, sorry, to give you, for sec, to give you 1 over x x squared minus 1, if I'm not mistaken. Yeah, that is for sec. Yeah, this is for sec. Can you try it for sec, or we can go together? Okay, let's do that. So given this, then we say y is equal to sec inverse of x. Meaning we have x is equal to sec y. Then we find dx dy What's the derivative of sec? It's actually tan y sec y. If you don't know, then you have a problem going forward. Then we are looking for dy dx, which will give us what? 1 over tan y sec y. Again, the relationship here matters. And which relationship are we going to involve here? We are going to involve the relationship for tan. Okay? Let's go. Tan squared y plus 1 we said is equal to sec squared y. You recall, right? Meaning, if I have to make tan the subject of a formula, this will be equal to what? Sec squared y minus 1 square root, which is plus or minus. Now, if I come to substitute here, okay? If I come to substitute here, isn't it? I'm going to have sec y, then sec squared y minus 1. But what is sec y? Sec y is x, meaning we have 1 over x outside. Here we have x squared minus 1. It's the same thing that we had here. So this is a scenario, meaning you need to know the identities that these trigonometric functions share. It will be very easy for you to move on like that. Okay, meaning you can now integrate any function which they give you, as long as you are able to express it in this way. Okay, now do try for cosec. Try for cosec and also try for cot, the inverse of cot.